As unfortunate as it might be, I did not record me solving this. It's macroeconomics, and I'll explain the story, and then I'll go over some tips and tricks to help you out. Okay, so this is our land per capita at time t, right here. This is our productivity at level at time t, and our income per capita at time t. And this is a Malthusian economy. So our job is to show how A, which is our productivity growth rate, and NT plus 1 less NT over NT, which is our aggregate population growth rate, affect YT plus 1 less YT over YT, which is our income per capita growth rate. Okay? So here's some tips and tricks. You see this? Your YT plus 1 less YT over YT, which is this. You can make it this easy, okay? YT plus 1 over YT less 1. Like 100% what you're gonna wanna do, because if you leave this YT up here, like it's very solvable, but you're just gonna have to write another line of math. This way, you've got AT plus 1 times XT plus 1 to the power of alpha over AT, XT, alpha, all less 1, okay? And then the next trick, I really like this one, is you can separate your land per capita, okay? And then you get this, big X over N to the power of alpha. But this is all to the power of alpha. So this isn't actually correct, sorry. X over N. So you've now separated this, and then you can separate it once more. So this is really cool now. You've got AT plus 1 over AT, and you've got NT plus 1, NT plus 1 over NT. And this looks almost like a rate, which is what we're supposed to be showing here, right? We're supposed to be showing the productivity growth rate and the aggregate population growth rate. So literally all you do is in each of the brackets, in each of the bracketed areas, you just add plus 1 less 1 to either side, because it's the same thing, right? Plus 1 less 1 is 0. You've changed nothing. But then you can change these into actual rates of change, right? So now you got 1 plus A, so 1 plus the productivity growth rate, times 1 over 1 plus NT plus 1 less NT over NT to the power of alpha less 1. And this is your answer, okay? So I'm going to quickly run over each trick. First trick, just to save you some time, change this growth rate into this. So it looks like this. It's just an easier way to work with it. And then also you kind of bring it back down here. So it'll put you in the right thinking for what sort of problem solving you're gonna need, okay? And then your next trick is to separate your land per capita at time t and make it look like this, because then your x's disappear, right? Because x over x equals 1. So that disappears. It's just 1 over nt plus 1 over nt, okay? So that's your next trick. And then finally, it's to add 1 and less 1 to either side, and then you're left with the solution. We have shown how the productivity growth rate and the aggregate population growth rate affect the income per capita growth rate. That is our solution today. My apologies for not running it all through as I was solving it, but stuff happens. And we're going to be going over more macro later. We're playing with very similar things. So we're doing the Malthusian model right now. I'm going to be going over a bunch of questions, and then we're going to be doing the solo swan model. We might eventually do some more like, I think it's like a dynamic stochastic general equilibrium models, which are more recent and also more tricky, but I think they're worth going over as well.